Hi, this is David Roach, Quantum Economics and Independent Strategy. Whoever you are, wherever you are, whatever you're at, hello. Today we're going to talk about loops and not quantum mechanical loops, which reconcile Einstein's theory of bent space and gravity with the flat background of quantum economics. We're going to talk about economic loops. Now, there are two types of loops. There's a feedback loop, and there's what I would call a feed-forward loop. What's a feedback loop? Well, if you have a major economic crisis in which, let's say, the exchange rate causes the value of banks' assets to deteriorate because, let's say, they borrowed all the money to lend in a foreign currency, which has just got more expensive, then the banks stop lending, and of course, people fear, so they stop spending, and the economy goes into a downward spiral. We've seen this umpteen times in the last 30 years, and that is, when you look at it and analyze it historically, of course, a negative feedback loop. Now, it's a bit like a ghost story, really. If you meet a ghost, then the feedback loop is clearly that the ghost is dead and once had a life or something which in existence at any rate, and before that it was born and had parents, and that's the feedback loop. Okay, now we're not going to talk about that at all. We're going to talk about what quantum economics says about feed-forward loops. And I'm actually going to focus these remarks on a very limited numbers of areas and on one overall subject, which is climate change and the destruction of the planet. So the bottom line of this analysis is that feed-forward loops have got the potential to actually save human beings from destroying the planet without actually changing their normal greedy ways. Let's start at this point. We start at the point of renewables. If you put together power capacity made out of wind and solar, possibly waves, together with batteries operating today, they are, in terms of kilowatt per hour cost of electricity, approximately 1/3 as expensive as the other zero greenhouse gas emissions option of nuclear. And they're about half the cost of coal, oil, and probably even cheaper than gas, which is the most competitive of the sources that I have mentioned, except for renewables. Now, that actually means that as renewable costs are destined to fall probably about another 70% in the next 10 years, they have actually reached the point in comparative cost curves where on economic grounds alone, without the high principles of wishing to save the planet or the many species going extinct, it makes sense to replace fossil-based fuel and electricity power with renewables. And that would be fine. We can see there is a doomsday loop in not doing this, and we're well aware of it. It's the stuff now of science fiction movies, and of course, 4,000-page IPCC reports, which is that if we do nothing, then the moisture content of the air will continue to rise. Because it does, it will prevent greenhouse gases leaving the Earth. So the warming of the climate and the oceans becomes exponential. Countries, parts of continents, the poor areas of the world in particular, get virtually wiped out. Agriculture doesn't work in the same way. And we get a whole kick-in of things which eventually would mean the extinction of the species which caused this whole thing to happen, which is us. That's a doomsday loop. Now, I want to do exactly the opposite. You're used to hearing the bad news from me, so now I'm going to give you some good news. I'm going to take 3 positive forward feed loops. So forward feeding loops, which actually give us hope that we can actually exit the doomsday loops, which are involved in climate predictions on a do nothing about it basis. The first of these is that if renewables are competitive with fossil fuel sources of energy, then we can make our food in a completely different way. Actually, fishing and agriculture in a classic sense become unnecessary, costly, and extinct. And then they actually don't even rival how we can grow our food in a more efficient manner. They don't even rival them in taste. So essentially, what this would mean as commercial agriculture and fishing drop out of existence, we could rewild vast areas of the planet. Now, you might miss your Swiss cows looking over gates peacefully as a definition of happiness with a bell around their necks, but the reality is the air, the farts, the gas coming out of these animals on a global basis account for approximately 11% of greenhouse gas emissions. So you'll just have to keep a postcard of your favorite Swiss cow, but do without it in reality. The rewilding of the planet, of course, transforms it back into being a much greater carbon sink. And you can see immediately that there is a positive feed-forward loop here in that greater carbon sink would cut greenhouse gases further. And we would actually see greenhouse gases after a time, which it would take to absorb the damage we've done already and the gases we've already put up there in the atmosphere, which have not yet manifested themselves in warming, but will over the next 10 years. But ultimately, no Swiss cow equals positive feed-forward loop equals decline in greenhouse gases equals decline in global temperatures, which is self-reinforcing. Now, what else happens? Of course, greenhouse gas emissions from agriculture and fishing fall away. We don't need all those chemicals poured on the land, or indeed the slurry from the back end of farm animals, which pollutes our rivers and oceans, fills them with nice E. coli waiting to kill us. We move into a world of three forms of regeneration: soil, which is perhaps the least spoken about, but the most critical form of degradation of the environment which has happened. So we start to see regeneration of the soil, we start to see regeneration of forests, and we start to see regeneration of the oceans. That is an example of a positive feed-forward loop. And it all depends on one single thing alone happening. And that is that the competitive nature of renewables is allowed to disrupt the existing fossil fuel-based industrial matrix, which will defend itself politically through lobbying in all sorts of ways, including, of course, falsehoods, fake realities, and trying to persuade the voters that they are a part of the solution, whereas they, the fossil fuel producers, can only by definition, unless they give up producing fossil fuels, be a part of the problem. But essentially, that's the only mechanism that needs to change, and the rest cascades. You move automatically from that to the end of commercial farming and fishing. You move towards rewilding, because what else are you going to do with the land? That kicks into our emissions of greenhouse gases. And those gases, that process of itself leads to the regeneration of the three pillars of our environment, namely, of course, the land and soil, the forests, and the oceans. Now, there is one other forward-feeding loop I'll deal with because it's obvious, and that is how this would affect transport. Well, first of all, if we can all move our goods and ourselves with renewable power, either through electric vehicles and batteries or whatever, then of course transport stops emitting greenhouse gases, which would be a major factor. We wouldn't need the traditional fuels anymore. And again, you can see quite clearly yourself that that immediately feeds forward into the loops of a stop or a diminishment of land destruction for roads and transport, less accidents, and the renewal, of course, of oceans, soils, and forests. But there is one final forward-feeding loop I'd like to put into your minds, and that is the one of the superproduction of power, which would occur if we replace fossil fuel-based power generation with renewable power generation. Now, how this works is this. You would have to install a capacity in renewables, which would cope with peak power and be able to store in batteries enough power to deal with the periods when it was either dark or the wind was not blowing, and so on. Now, that means that in a normal cycle, you are actually installing capacity in excess of demand. So during the periods, let's say when the sun is shining and the wind is blowing and the currents in the sea are doing what currents do and moving our sea turbines, in the days that that is all happening harmoniously in nature, you are actually producing far too much power because the need for that power would be much less than the capacity which would have to be installed to cope with peak power loads on bad days or nights when the renewables were not generating. The excess power, which is created on a normal day, I call superproduction. Now, what does superproduction do? Well, it actually gives you the ability, together with battery storage, to provide enough energy to transport the heating or cooling of houses and to most of the supply side of GDP for free. Essentially, the excess amount of production would be taken out of capacity which would otherwise stand empty. And that capacity, that amount of extra production, can be sold off for virtually nothing or very little, leading to the forward-feeding super change of whole sectors of the economy, which would otherwise be hesitant to change because of the pricing of renewable energy, which would nevertheless be cheaper than its alternatives, but just hesitant to change, humans often are. They could not but change because essentially you would be auctioning off superpower stored through batteries so that it was available all the time and not just between 9 o'clock in the morning or 5 o'clock in the morning and when the sun set. It would be available all the time because it would be stored when it was not directly used. And that superpower would be available to all the factors of production and indeed to private individuals in their houses, their homes, their electric cars, at a cost which would be as close to nothing as you can be. Now, you cannot provide a better motivation to people, greedy as they may stay, as they may remain, to change, and to change things which then change the climate and lead to further forward-feeding loops, which make you a reverse tipping point in which things get better rather than worse for the climate. It makes that inevitable. That's my message today, that when we look at economics, we don't want to look at the supply and demand curves for single sectors, and we don't want to look at them in a single time frame. You have to integrate into your analysis the concept of forward loops. Forward loops have been used by economists as feedback loops to explain the past, as I described in my ghost story. But what we really have to do is to integrate these into the forward loops, which will set the economic path. Indeed, it may set the stage, which will answer the question as to whether there is going to be a global economy or there will not be a global economy, whether there will be people or there will not be people on the planet. They may be the absolute key to producing the right sort of analysis, and at the same time, to provide us with some hope. So bottom line is continue to invest in renewables, continue to invest in all the sectors which will be affected by the positive feeding forward loops of changing the way in which we produce energy, which can be achieved by markets alone. If we do not allow powerful lobbying groups from fossil fuel producers and users to get in our way, and if our governments, God bless them, can be endowed with even a modicum of forward vision rather than just dealing with the last crisis. Goodbye, good night, and don't turn off the light.